Globally, network traffic jams cost businesses over $700 billion annually in lost productivity. Yet most people have never heard of the technology that prevents these digital gridlocks.
That's quite the price tag. And you're talking about EtherChannel, right? The hero for hire that can keep our data flowing smoothly?
Exactly right. You know, I was thinking about this the other day when my entire office building lost internet connectivity for just 15 minutes. Absolute chaos erupted. Thankfully, we have a Starbucks nearby.
Well, that must have been quite the scene. Though I imagine most people don't realize there's this incredible technology working behind the scenes to prevent those kinds of disruptions.
That's what fascinates me about EtherChannel. It's like having multiple backup generators running simultaneously, but for network traffic. The technology can combine up to 8 separate network links into what appears to be one superhighway of data.
Well, folks, welcome to Technically You. Today we're diving into something that might not be the flashiest part of networking, but it is super important for keeping data traffic flowing efficiently and reliably. EtherChannel.
That's right. Whether you're running a data center, a large enterprise network, or just studying for your next certification, you're going to want to understand how EtherChannel works. So let's get into it.
So let's start with the basics. EtherChannel is a Cisco term. In broader networking, it's referred to as link aggregation. The idea is simple. Bundle multiple physical Ethernet links together to form one high-bandwidth logical link.
And this bundle behaves as one logical interface from the perspective of your switch or router. So if you take, say, 4 1 gigabit per second links and bundle them using EtherChannel, you essentially have a 4 gigabit per second aggregated pipe. The switch sees it as one big road for traffic to travel on.
What's wild is how seamless it is. Instead of managing each interface separately in protocols like STP or OSPF, they're treated as one. That's not just good for performance. It's amazing for simplifying configuration and management.
So you might be wondering, why not just use faster individual ports instead of bundling slower ones together?
Great question. Not every device supports 10G, 25G, or 40G links out of the box, especially older hardware. EtherChannel gives you a way to scale bandwidth horizontally using multiple standard speed ports like 1 gig or 10 gig.
Plus, there's redundancy. If you lose one of those bundled links, like if a cable gets unplugged, the others keep running. It's kind of like RAID for your network links.
As a networking geek, I like that. RAID for ports, and don't forget load balancing. EtherChannel can distribute traffic based on hashing algorithms, source IP, destination MAC, layer 4 ports, so you're not overwhelming one link while others sit idle.
So, how do these links come together and agree to play nice? That's where negotiation protocols come in.
Right, there are two main protocols, PAgP, Port Aggregation Protocol, Cisco proprietary, LACP, Link Aggregation Control Protocol. The open standard, defined by IEEE 802.3 AD.
If you're in a Cisco-only environment, PAgP is fine. But if you're mixing gear, say, a Cisco switch and a Juniper or HP switch, LACP is your go-to.
Exactly. LACP negotiates the bundle across devices and ensures both ends agree on which ports are part of the group. You can configure LACP in either active or passive mode. Active sends and responds to LACP messages. Passive only responds if it receives LACP messages.
And if you want to force things manually, no negotiation, you can do a static EtherChannel, where both ends are manually configured to act as a bundle. But if the config doesn't match perfectly, boom, problems.
So let's say your EtherChannel isn't working. What should you check first?
1. Check consistency across all physical ports. Run Show EtherChannel Summary or Show PAgP/LACP Neighbor, depending on the protocol. Step 2. Look out for mismatched native VLANs or trunk modes. One side being access and the other trunk? Not gonna fly. Step 3. Watch out for switch model limitations. Some lower-end switches only support a certain number of Ether channels, like 6 or 8. Others may only support LACP in specific iOS versions.
Thanks. Now here's something most people forget. Spanning tree protocol treats the entire Ether channel as a single link.
That's a big deal. Without EtherChannel, multiple parallel links between switches would be blocked by STP to avoid loops. But with EtherChannel, STP sees one logical connection and leaves it open, letting you use all your links.
Total bandwidth gain and loop prevention, that's a win-win.
So where do we actually use this? Switch-to-switch uplinks in access, distribution, or core layers. Switch-to-server setups where the server NIC supports bonding. Between firewalls for redundancy. Even virtual switches in data centers, like VMware's vSwitch or VDS, support LACP.
And some vendors have taken it even further. You've got VPC in Cisco Nexus, MLAG in Arista, MCLAG in Juniper. These let you create a port channel across two physical switches for even more redundancy. One logical switch, spread across two boxes.
It's next-level resilience. But it all starts with understanding the basics, like EtherChannel.
So here's what you should walk away with. EtherChannel equals link aggregation, used for increasing bandwidth, adding redundancy, and simplifying management. Uses protocols like LACP or PAgP. Careful configuration is crucial. It plays nicely with spanning tree and works in most enterprise architectures.
If you're in networking, this is one of those core tools you just have to know. It's reliable, battle-tested, and super handy once you get the hang of it.
That's it for today's episode. If you learned something new or had an aha moment, share this with a friend or teammate and leave us a review.
And don't forget to subscribe for more tech insights and nerdy breakdowns, right here on Technically You. Until next time, stay curious, my friends.